Recording. Okay, so we are in section 4.1. We're continuing to talk about section 4. Well, that's kind of, hold on here. The stylus is not there. We can be neater. Section 4.1, which deals with subvector spaces and subspaces. And I have an example here. Okay. Let H be the set of all vectors of the form, okay, and well, the form is going to be this. These are the components: a minus 3b, b minus a, and b. Okay. So H, if we were to write it out a little more formally, these would be the components: a minus 3b, b minus a, and b. Those vectors such that a and b are in R. In other words, they're real numbers. Okay. What we want to do is we want to, well, my question is H a subspace? Oh, let me be more clear. Is H a subspace? Thank you, Mikhail. Of R what? What if H were a subspace? What dimension would it be? What dimensional subspace would it be a subspace of? Where does this space H live? Does it live in R1? Is it two-dimensional space, three-dimensional space, four-dimensional space, five-dimensional space? Well, how many entries do you have here in the vector? How many components? 4, right? So if it is a subspace, it's going to be a subspace of R4. Now for the solution, the answer is yes. This is a subspace. And the reason is this. If we take the vector can we write it as, so if we take a vector in space H, can we write it as a linear combination of, say, a vector v1 and a vector v2? Well, hold that thought. Hold that thought, Mikhail. So I'm wondering if there are vectors v1 and v2 such that this vector in space H, coming from space H, so the components have to be of the form a minus 3b, b minus a and b. Mikhail says yes. Okay, what's vector v1 going to be? Right. Good. 1, -1, 1, and 0. What's vector v2 going to be? Good. -3, 1, 0, and 1. Now, please let me know if you have any questions on that. Please let me know if you have any questions on that. Who's feeling good so far with this? Okay, Mikhail is. Who else? Belen is. Well, good. Well, how does this show that space H is a subspace? What do we know about H? If any vector in this space H can be written as a linear combination of vectors v1 and v2, H would be the what of v1 and v2? There's a word I'm looking for here. Well, not v1 plus v2. Good try though, Belen. I'll give you a hint. It begins with an S. There, that's right. Good, Mikhail. The space H is the span of v1 and v2. Right? This space H, this subspace of R4, is the span of two vectors. And since H, the space H, can be written as the span of two vectors, this means that H is a subspace. Because we learn that the span of any set of vectors is a subspace, because it meets the three properties of a subspace. So since H, well, H is a two-dimensional subspace of R4. And since H is the span of those two vectors, v1 and v2, this means then that H is a subspace of R4. So there are a lot of problems in your homework where it says, is this space a subspace? And for certainly some of them, all you need to do is show that the space is the span of a set of vectors. And then you've proven that that space is a subspace. Okay, are there any questions on that? Okay, let me stop this recording then.